In this video, I will explain the hardware of a simple computer. To begin, I will explain the instruction memory. This is the component that holds directions for the program. The instruction memory is an ROM, read-only memory, different than RAM, random access memory. Instruction memory can have different formats that affect the length of the opcode and following registers. The instruction memory is always an array of bytes, like all memory. So, how does the computer know when to execute each line? Well, the PC, the program counter, is an instruction pointer. Another name for this is the IAR, the instruction address register. This holds the memory address or points to the current instruction that would be executed. The program counter is usually incremented after an instruction is fetched and points to the current instruction being executed. In this diagram, the program counter is incremented by 4 address locations. 4 was not randomly chosen. In ARM assembly, the instruction memory is 32 bits, so the incremented amount is 4 bytes. The control tells the program counter the place in the instruction memory to execute. Typically, this is done sequentially and increments the address correlating with the next instruction. However, the control can be sent a signal from the decoder, such as a branch, a jump, or a subroutine call, which will tell the program counter to move to that particular instruction. In this diagram, the decoder works as a multiplexer, where it takes in signals from the ALU and the opcode, decodes it, then sends it to the control, which will pass it on to the program counter. So, for example, if the instruction is supposed to compare A and B, then either continue or jump to C, the decoder needs the ALU to give the comparison and needs the instruction memory to give directions on what to do based on this comparison. Next, I'll explain the register file. These are registers that are hardwired in the computer and hold numbers. What these numbers represent is situational, could be a value or an address. The register file is an array of processor registers in a CPU. These registers are usually implemented in fast memory, and the architecture of a CPU will almost always define a set of registers that are used to transfer data between memory, the ALU, and other hardware components. Instruction memory holds the directions on what the program should perform. A line of instruction memory has these components. There is an opcode indicating the operation that should be performed. There's also a bit that indicates read R or write W. A read accesses the information in a register, while a write places information into a register. In example 1, add is the opcode, A and B are registers, and C is the destination register. This would translate to the following line, C equals A plus B, in a higher level language such as Python. What this line is truly doing is taking the values in registers A and B, adding them in the ALU, then placing or writing the result in register C. This is a scenario where write would be used. In example 2, the instruction to branch to an address, B address, would be translated by the decoder and sent to the control, which results in setting the program counter to point to the address and perform the instruction there rather than the next address. When the decoder sends the control signal, this overrides the incremented instruction which would normally be used. This is a potential scenario where read would be used. The ALU stands for the arithmetic logic unit. This is the piece of the computer that handles arithmetic, such as addition, subtraction, etc. Additionally, the ALU does logical comparisons, such as greater than and less than, etc. Lastly, I will explain the clock. The clock is an oscillator or a crystal that can be divided down by hardware and software to provide the necessary timing signals for the hardware. The clock is always a precise square wave that is used for timers, clocks, and interrupt routines. This can also be used for inputting and outputting data from this computer. The importance of the clock is to allow the program to have an order and to be able to be stepped through. Without this, every command would be executed at the same time, and memory would not know what values, variables, and addresses should hold.